this is Miss O'D.
And Miss Hughes.
All right, in today's podcast, we're going to talk about two new rules that you haven't seen before. The first one we're going to look at is called the sine rule. What's important to remember is the two rules we're going to use today are only for non-right angled triangles. So we've looked at SOHCAHTOA before, and SOHCAHTOA only works for right angled triangles. So now we're going to have another rule, or another two rules that are going to help us be able to find sides and angles for any type of triangle. So the first one we've got today is called the sine rule. The sine rule is a ratio of the sides and the sine of the opposite angle. Now when we name angles, we use capital letters in a triangle. So we can see this triangle here is triangle ABC, and we've used capital letters there. When we label sides, we use small lowercase letters, and the side opposite the angle has the same letter but in lowercase. So we can see here angle A, the side opposite is side A. Then for angle B, the side opposite has the lowercase b there, and similarly for C. So this is important to remember because you need to make sure you have the right letters with the right angles. So with our sine rule, we have that the side A over sine of angle A, that ratio, is the same as side B over sine of angle B. And similarly, that is equal to side C over sine of angle C. Also, because all three of them are fractions, we can just flip them upside down, so we can take the reciprocal of them, and we just have it the other way around. So we have it so the angles are on top. This is sometimes useful when we're finding the angle, but we'll get to that later on.
Should we just try an example?
Yeah, let's put this into practice. So here we have a triangle. We know the angles 32 and 46. And we have the side 15 centimeters, and we want to find the length of the side that's x. What's important to remember here is what information you need to use the sine rule. So we need an angle and its matching side. We need to know the angle and its matching side. Okay, so we know the 46 and the side opposite is the 15 centimeters. So we'll call that its matching side. Then whatever we're trying to find, whether it's the side or the angle, we need to know the matching side or angle that belongs to it. So here we're trying to find the length of x. So we must have the angle that's opposite, which luckily we do here. We have the 32 degrees. So we can say then, using our rule, should we maybe write the rule out, Miss Hughes? A over sine of angle A is the same as B over sine B. Now you can write all of them out. You don't have to, because you only need to have 3 pieces of information plus the one that you're trying to find.
And why did you choose to put it this way around rather than the other way around? Because there was also this way.
Good question. As I mentioned before, it actually doesn't matter which one you use. However, if you're trying to find a side, it's just easier. There's less working out to do if we have the sides on the top of the fraction in the numerators.
Good.
If we're trying to find the angle, then it's just easier. It's just a little bit less work with the algebra to have the angles on top.
Good.
But it actually doesn't matter.
Okay, so we're going to work with this one.
So yeah, let's work with the top one. So remember, the A's and B's, they're really irrelevant. We can call them anything we like. It's all about the position. So we need a side and, we'll start with the side that we don't know. So we'll have x on top. And that's going to go over sine of the opposite angle, its matching angle, which in this case is 32 degrees. So we know that that ratio must be the same as 15, because that's the side we know, over sine of its matching angle, which in this case is 46 degrees. Okay, so now we have an equation that we need to solve. So just like any other sort of equation that we try to solve, we want to try and get x by itself. So because x is being divided by sine 32, then we do the opposite, so we multiply by sine 32. So if we multiply both sides by sine 32, we have 15 times sine 32 over sine 46. Now we have x by